Awesome. So, yeah, my name is Kyle Hoyer. I'm one of the principal engineers on our Fast Track for Azure team. Been supporting these types of deployments, specifically where we, attempt to be SCCA compliant for a number of years now. Been covering DoD for about 10 years. And so, again, like Mike covered, the mission landing zone is very specifically opinionated and very specifically meant to adhere to requirements laid out by DISA for a lot of this SCCA compliance. Again, we also see customers using these more broadly for services like TIC and or other government security type landing zones or reference architectures that are already commonly used. But again, that was the initial driver that led to a lot of this. So thank you, Mike, for covering the overview. And now we will walk through really what it looks like within the GitHub repo. Again, this is something that is public. It is available for anybody to go and download the code. You can use it, modify it, deploy it, do with it what you will. We also always are open to recommendations if you want to create a pull request and or submit bugs and or recommendations for the code. Please do that. And I think we'll be including the links for these as well. But I wanted to make sure that I did highlight the Secure Azure Computing Architecture page for our blog that we maintain. This is specifically a socket document that we use to give an overview of really how Microsoft and how Azure specifically is adhering to these reference architectures to speed up time for customers to get connected on these networks, right? So we walk through a lot of the requirements, again, within SCCA, and we have listed a number of reference architectures, the first one being the mission landing zone code. So you can see the diagram here that Mike had previously shared. If you guys were to go to aka.ms/SACA, this will take you to this link, and there is a GitHub link that you can click here. This will simply take you over to our Mission LZ repo, which you can also get to either via this link here or via missionlz.com. So once you're in the repo, we obviously have a very good README that really walks you through, again, some of the basics. What is the goal here with Mission Landing Zone? What are we adhering to? Why is it important to you? Maybe why would you want to deploy Mission Landing Zone? And then we walk through some of the steps in order to actually deploy this through Azure CLI. And so you'll see a number of really basic commands, as well as the recommended default components here that you're going to want to enable for things like name, location, parameters, etc. Right? And so we'll spit out an example. And again, I will show you this, but today we're focusing on the Bicep deployment. Previous to Bicep, we also built out and support a Terraform deployment. So if there are examples where in your environment, I have customers that already do this today, if you are very heavily invested in Terraform and that's something you are already very familiar with, and it's something you want to integrate to something that you potentially build and deploy and destroy continuously, obviously we have that available. There are, I would say, a number of reasons why we have migrated to the Bicep model. One of them very specifically being so that we can have future support on our side, as well as the ability to bring Mission Landing Zone directly into the Azure marketplace. And so that's something we'll look at in the portal as well. But again, looking at these diagrams, these are things that Mike had already shown you. These are on the, I'll call it the homepage for the repo, for the README. And if you were to go into the source folder, you'll see that we have both Bicep and Terraform. If we walk through the Terraform side real quick, we have a separation between the Mission Landing Zone as well as the Tier 3. So historically, as well as the way we maintain it today, we have separated the Tier 3. I call them mission owner environments, where effectively the default deployment for Mission Landing Zone will get you the base, Tier 0 through 2 architecture, which gets you the hub and the spokes for identity, operations, and others. And tier 3 really being mission owner workload onboarding, in which there are separate deployments and or onboarding steps that I think the benefit of us pulling that out from an automation perspective is it gives you the ability as the admins to then create additional automation and or decide what that environment looks like and how you stig that environment or whatever it may be for these applications that you're onboarding. So if we dig into the MLZ, you'll see that if you're familiar with Terraform, you'll be familiar with this variables.tf file. Within here, we have obviously a lot of defaults. There are things that if you were deploying to Azure Government, for example, you would have to modify the defaults to ensure that you have the appropriate environment switch as well as the appropriate API endpoints for this to deploy. But everything else is pretty self-explanatory once you define the environment, the endpoints, the region you're actually going to deploy to. It's a very common theme that we depend on, and let me zoom in on this real quick if it makes it easier. We create this concept of these resource prefixes, right? So one of the challenges within Azure, especially when you're spinning up, again, for folks that are familiar with the automation side, when you're creating a large number of resources, there's always naming constraints based off character limitations, lengths of names, what's required minimum. And so what we've done is we've created this resource prefix that must go before any of the other names. Then we, at best possible effort, randomize some of the other ones that have more strict requirements, something like a storage account, right, where they have to be globally unique. You could then obviously choose to enforce tags. And then the rest of this really digs into some of the stuff that Mike had talked about, the ability to deploy this to separate resource groups per tier, or the ability to utilize a single subscription and move them into separate resource groups, right? So either a separate subscription for each tier or separate resource group, just really depending on how you design and architect the permissions and governance for your environment. And then the rest of this, I will skip over for now. A lot of it is understanding how the firewall deploys, understanding your VNet address space for each of those spokes. I want to jump over to the bicep side, and I can show you what that looks like on that side. So again, there are READMEs for each of these deployments, and I feel like we've done a pretty good job of conveying what the minimum requirements are, as well as what the additional optional switches are that you can enable as part of this environment, right? So on the bicep side, you'll see obviously we have resource prefix again here. This is a required component at a minimum. And then there's a number of things as we scroll down that become optional, where if you were to choose not to put any input here, it would just fall back to our default values, right? And so things like different separating out the subscription IDs for each of the tiers, tagging, location, specific components within firewall. These are the VNet address prefixes again. And then the ability, I want to make sure we scroll down here and highlight some of the additional components outside of the traditional hub spoke. And these are things that Sherry will dig into, but the option to enable Sentinel and or create remote access where we could deploy the Azure Bastion service along with 2 Jumpbox VMs. So if you were to choose the remote access option, we deploy both a Windows and a Linux Jumpbox with only private IPs, and then we utilize the Azure Bastion service in order to jump into those VMs. Again, I think that's a huge component where we're limiting the footprint publicly that's available and creating a more secure environment out of the box, which gives you less work in way of having to lock that down later. And then there's more components down here. Specifically, do you want to deploy policy? If you do, okay, great. These are the 3 that we offer today as part of the deployment. You could choose either to be NIST 800-53, DoD's Impact Level 5, or CMMC. And also these are things that Sherry will dig into and do a little bit more show and tell on as well. And then last piece really being Defender. So as you walk through the different bicep deployments, the ability to take these parameters and decide before your deployment, what do we want to enable? The things that we are going to enable, how are we naming them, and why are they important to us? And then from there, you can kick off the actual deployment, and we can walk through that real quick here in the portal, and then I will show you what it looks like post-deployment, what you're getting at a bare minimum. So I've logged in here to the Azure government portal. You can see in the top left here, it says Microsoft Azure Government. We are at portal.azure.us. That is important as the commercial URL is .com. And for those that are not familiar, I always love using this Cloud Shell option here. So this is built-in PowerShell and Bash that really is super helpful. I no longer have to update all of the backend PowerShell commandlets and information on my local desktop. You can keep it updated here within the UI, and we include also within Bash things like the Terraform commandlets as well, right? So you could come in here directly to Cloud Shell, run Bash, and do a Terraform deployment, for example. So to walk through what each of those would look like, if you were to open up Cloud Shell, we went back to the Git repo. If we go to code and copy the URL, we could do a git clone and paste the URL. We'll get an error today because it already exists. If I do an ls, you'll see that I already have a mission LZ directory here. I also have a tf-mlz that I use specifically for running Terraform test deployments. So if you were to dig into, say, the mission LZ directory, you could go to source, and then from here, you have the option for both Bicep and Terraform. If we take a quick peek inside Terraform and drop into the MLZ directory, again, for those that are familiar with Terraform, you will understand the main output and variables TF. If this is already a repo that we had cloned and or forked and or pulled locally, modified the variables to put our information in there, right? I mean, a lot of times this is something that when I'm doing deployments with customers, we will pull down these locally, modify the variables, and then upload into this Cloud Shell storage accounts because obviously it could potentially hold secret information like passwords and or IP address space that you don't want published publicly on your Git repo. So from here, I will not be running these commands, but from here, you could then run your Terraform init, you could then run the plan, and then you could run the apply auto approve, and 15, 20 minutes later, you would have a mission landing zone built out environment utilizing the Terraform scripts. So if we go back and now run into the Bicep directory, you will see that we have a mlz.bicep file here, right? And so this mlz bicep file, let me go over here and just pull this up real quick. This file is specifically what we would be using to call out the different parameters that we had covered previously that we want to enable, and then it will use that to deploy. And so to give you a good example here, this would be a sample deployment of the code you would use in order to deploy via Bicep. I'm doing an AZ deployment sub create. I'm naming the deployment itself, test deploy. This is simply just referring to the actual Bicep deployment. I'd be deploying it to Azure US Government Virginia, again, pointing to this mlz.bicep file that we were just looking at, and then simply deciding which parameters I want to enable by inside my deployment, right? So there are obviously minimums that you have to have, again, resource prefix. And then there are optional pieces that you could enable, like I have done here. I have different, let's see, I have different subscription IDs for each of the tiers. Again, this is something that if you were to leave default, it would simply deploy to your single subscription with multiple resource groups. And then this is a default option. I like to define it, but what's really important here specifically for MLZ is because we're trying to adhere to SCCA compliance, the firewall SKU really does need to be premium, and we can dig into kind of some of the capabilities that that's providing. But that's a big component here. And then really the rest of the stuff that I'm defining is nothing more than all of the VNet address space, as well as the different subnets for each of those virtual networks that I want to carve out. And you can see that there's two pieces here, which I think are important, and they're fairly common with the customers that we deploy this with, at least within DoD. They are going to deploy policy, and regardless of what the policy is that deploys, I think the ability to onboard and automate and onboard the policy initiatives here is a big help. And then obviously the ability to enable the remote access. Again, what that's doing is deploying Azure Bastion, as well as two jump box VMs. One is Linux, one is Windows. And again, an important piece here is that none of those have public IPs. These are only accessible via the Azure Bastion service via port 443. And then, last bit here really just being the passwords you want to set for each of those VMs. So the last piece that I will jump into is showing you guys what this looks like post deployment. So let's just say that we ran through a Bastion deployment. We ended up utilizing this command that I have set here. If we hop over to resource groups and filter this on MLZ, you'll see I've got 4 resource groups: the hub, identity, operations, and shared services. And while we hop into the hub, I would say this is definitely by default the most important resource group. This is where the bulk of things really are happening from a security perspective. So you can see we have the Bastion service. We'll look at what that looks like from a VM perspective. And then you have the Azure firewall as well as the default Azure firewall policy. And so if we jump into the policy real quick, you can see the firewall and its policy itself are both premium tier. And if we go look at the rule collections for a second, I do want to highlight that we don't create very many, but we do create a couple default network rule collections as well as a single application rule collection. And so the point really here of these is that we're allowing, and if I go to network rules real quick, we're allowing the traffic from spokes to be able to talk to each other internally, as well as the ability to communicate within this concept we call Azure Cloud, right? So this is a tag that we use in order to wrap all of the Azure Fabric backend services and address space into a single tag that you could then use to define for things like your source and destination traffic, right? So I think that's one of the beauties of utilizing, again, an Azure first-party product for some of these capabilities is that within your firewall routing rules and firewall rules, you can create service tag based routes that say if it's in the Azure Cloud tag, we would allow it or deny it, right? And we can modify these. I can show you what some of the different tags are. Obviously, there's a number of different tags that are more specific for individual services. But again, the purpose of this Azure Cloud tag is that it should be a culmination of all of the backend Azure Fabric and services. So the assumption here is that by default, we expect you want to be able to communicate within the Azure backplane, right? So, and then we have one application rule here. This is very specific for Azure authentication within internally to get to some of the Azure Active Directory endpoints. The rest of the content within the hub here is a lot of supporting resources specific to the VMs and or to some of the what we call private links or private endpoints, the ability to bring Microsoft public resources into the private address space so that you're no longer required to route external the environment to get access to those things like storage account, for example, right? And then the last thing we'll look at within this resource group is the virtual network. So I just want to make sure I show you based off of the deployment that we used, you can see the VNet address space that was defined. as well as the multiple subnets that were cut out for the firewall, the management subnet to carve that out so we could do default routing as well as things like Bastion. We also, by default, create what's called VNet peers with each of the spokes. And we'll go look at those real quick, but each of the spokes has a peer directly back to the hub VNet. And then they have a user-defined route to shape the traffic that says, if there's no system route for anything local to your VNet, we will be default routing it back to the firewall private IP. So if we go look at one of those real quick, if we hop into the identity resource group, for example, you can see there's not a lot that we deploy by default other than potentially staging the resource group for you, as well as putting the virtual network in place with the predefined address space and subnets that you had defined during the deployment, as well as created the peering to link it to the hub. And the last important piece here as part of these spoke resource groups is that we create a user-defined route. Again, you'll see at a minimum, this is pretty bare bones, but we create a default route that just says, if you're not authoritative for anything within your local VNet, you need to send that to the Azure firewall to then be transited to any other spoke and or potentially exit the environment, whatever that may be. Again, going back to the default security model, I think this is pretty massive because the only way in or out of the environment is through the firewall in the hub. And the last piece that I want to cover within the portal is specifically this operations resource group. And so you'll see a number of things in here that are called solutions. We create a log analytics workspace, which then within here, you can come in and view the different solutions as part of this log analytics. Really, all we're doing here is creating a place that everything that was deployed has the ability to go drop its logs and important information into this log A workspace. And then it's up to you to decide what you may or may not do or what services you may or may not enable in order to act upon these logs that are being dumped, and or maybe you want to visualize it or whatever that might be, right? So really we're pulling these components in, we're bringing the logs for you by default into operations, which really just is enabling you to decide how you act upon those logs, and maybe some of it's important, maybe it's not. And then just to show you this last resource group, shared services, is going to look identical to identity. Again, we're just creating the pre-stage of this virtual network, again, defining the address space and the subnet, as well as a user-defined route that sends all non-local traffic back to the Azure firewall. So that covers really what we have within the Git repo. Again, this is all public. I would welcome people to go out and take this code and deploy it, and or submit recommendations if you think that there are things that we are missing by default that you think should apply to everybody, and or potentially adding additional parameters that you think are missing that would be important. Please do so. And I will now hand it over to Sherry to cover the compliance and security aspects post deployment of MLZ.